Hi, hello everyone. So as we said, my name is Dafna Mordechai. I'm a real-time embedded software engineer. I studied computer science in the Hebrew University, and since I've graduated in 2008, I've been working in the industry for different companies and different embedded systems. I love technology, I love sharing it with others, and today I want to share some of it with you. In the past couple of years, I've been working for Automation. Automation is a startup in Tel Aviv, developing an end-to-end IoT platform. Our solution and technologies are integrated in our partners' solutions for IoT. This is a personal talk. I'm not speaking here on behalf of Automation. Today, I want to tell you about a workshop that I created a few months ago. It was part of a whole-day conference for engineers that were organized by the Ba'ot organization and was sponsored by Microsoft R&D Center in Israel. We had a full day with 100 engineers with 3 different tracks about low-level and security. One of them was reverse engineering, the other was virtualization technologies, and my track was about embedded systems. As a result of this day, I created a lot of materials that are now shared online for free, and I want to show you them today. So what we're going to do is we're going to have a brief overview about IoT, and then we'll talk about how did I create this workshop, because knowing the bits and the bytes of things doesn't mean that you know how to teach it. And eventually we'll go over the actual content of the workshop and the exercises that were there. So IoT, or the Internet of Things, refers to connecting machines and other physical objects to the Internet, usually in order to gather information from sensors and to control the system from a distance. Some reports says that by 2025, there will be over 55 billion IoT devices connected. That's huge. The main components for IoT is what you can see here in this diagram. On one end, you have the IoT devices. They usually have sensors, as we said, and some of them have actuators, and they have some sort of communication. Wireless communication is a key component for that. And eventually what they want to do is they want to transfer all the information into the cloud service, so you can monitor all the data from there, you can run analytics, and you control things from a distance. In order to do that, usually there's an additional component today, a gateway that can talk to the devices, gather the information, and upload it to the cloud. As wireless technologies will evolve and be deployed, and specifically the low-power wide area networks like narrowband IoT, we will see more and more devices that can upload the information themselves, and they won't need any additional gateway for that. So different things have different needs, and just like any other embedded systems, you can design to a variety of different systems. If you have a plant at home that you just want to monitor, and maybe you want to sample humidity and temperature twice a day, and you don't mind waiting for it a week and then coming with your mobile phone, gathering the information and upload it to the server, you can probably have something that is very low cost and will last a lot of years on a simple coin cell battery. But if you want to monitor, let's say you want to have something that monitors a lot of different sensors in a construction building or heavy industry, something that is more critical, and you want in real time to check all the sensors, maybe run some computation on it, check if some threshold was crossed, and if something happens, you want to set an alarm and maybe even send text messages to the site managers, it will be a complete different system. And it will need different resources. Just like any other design of embedded systems, it will have probably some other types of peripherals, and for sure the power consumption will be different and the cost will be different. And obviously there's a lot of systems that you can do in between. So let's take a real-world example. This is a machine monitoring system by Automation. You can see, just as we depicted before, you have these small sensors that are taking vibration frequencies. They have BLE abilities, Bluetooth Low Energy, so they can talk to the mobile app. They can be configured by the mobile app, and all the information can then be uploaded to the cloud using the mobile communication, like 4G, Wi-Fi, whatever you need. And then on the cloud, you can see all the road data. You can run FFT. You can do basically whatever you want with it. Okay. So now, when we know what IoT is, just in brief, I want to share with you two things. First is all the questions I needed to ask myself before I was creating a training set. And we're going to answer them, and then we'll see what decision I had to make. So first of all, every workshop has some limitations. Like the required subject matter was just about low-level and embedded systems. So I wasn't talking about analytics or cloud computation or other stuff that are related to IoT, because it was about embedded systems. A full day can sound like a lot, but you can see just like here, you have gathering time and opening talk and lunch and coffee breaks. So I calculated that it was about 5 hours that I need to make. And that's not a lot of time. And I really wanted to make sure that I can stretch the time somehow, and I'll show you how I did it. And I had a budget, but I wanted to keep it as low as I can because it was a sponsored event. But since I had a budget, I could do hands-on exercises because I could buy some hardware. The second thing I needed to decide is just what would be the main building blocks. So embedded systems and IoT, that's what I chose to talk about. I wanted some hardware hands-on, and I chose Arduino. I will tell you soon why. And I wanted to have another component that I would deep dive into, and I chose the Bluetooth Low Energy. There are a lot of other wireless communications that are in use. This is what I know, and I can only teach about things that I know of. So the big question is, what do we offer when we teach? And it may sound trivial because we have knowledge and information and we just pass it on. But I think that we can define it somewhat better. I think that when we teach, we provide structured knowledge that is suited to the participants. So who were my participants? They were software engineers. Some of them has a lot of years experience in the industry, but not necessarily with embedded systems. They could be mobile developers or web developers. I know that they can learn new topic quickly, and I know that they can code C and C++. What I cannot assume about them is I cannot assume any prior knowledge about embedded systems, and I cannot assume any prior knowledge about any specific hardware. So if we're going to use that or talk about it, I have to teach them. And another question is, what would be the learning methods? And I chose 3. And the first one was to send them preparation assignments before they even got to the workshop. In this way, I could stretch the time and make them learn more. And when they will be at the workshop, we all be on the same page, at least for some terminology. And it really bought me a lot of time. The advantage is that they can learn on their own. They can do it in their own pace. The disadvantage is they could just not do it and I wouldn't know. And that sometimes with different backgrounds, if I send them to read things, different backgrounds means different understanding and sometimes even misunderstanding. So the main important things I will have to repeat at the workshop itself. And on the day itself, I had frontal instructions and hands-on exercises. So I had 5 hours, but I needed to divide my time to that. So now I needed to choose a hardware to work on. And if you know some about Bluetooth Low Energy, different chips, you may know the evaluation kits. And that's what I thought about in the beginning. But actually, for people without any background, it's not so easy to use. I don't know if you worked with Code Composer Studio of Texas Instruments. It's fun. I wouldn't recommend it as fun for newbies. And I actually found online the Adafruit Feather Bluefruit LE, which is a really nice module, and it saved me a lot of time, and I'll tell you why. First of all, it's an Arduino compatible board, which means you have community and a lot of materials online. You can use the Arduino IDE that basically any 8 years old can use. It has a Bluetooth Low Energy chip, so I could do whatever I want. And it's wrapped up with a dedicated Arduino library by Adafruit. So they already wrote some of it. And they also wrote a mobile app to talk to this. So I wouldn't have to do the mobile side. I wouldn't have to code it myself, and they also wouldn't need to do that. So it was a really good solution for me. Last question was, shall I create everything from scratch, or shall I use things online? And as people already mentioned here before, there's a lot of content online. But then when you think about exactly what I want to teach, it's really hard to find it. And also, just the time that I invested in filtering things and going over materials, it was a lot of work. So I say do it whenever you can. I did it whenever I could, and I gave credit to the authors, and I sent links and articles and videos, but it wasn't as easy as I thought it would be. Great. So now that we know all of that, we'll dive into the actual content. I must say that if you know more about Arduino or about embedded system, obviously, or about Bluetooth Low Energy, I guess some parts you will understand a bit more. So the questions that we actually are answering now is, what are the learning goals for the participants? And how can we organize and structure the knowledge and the information so it will be easily understood? I left the graphics here, just the way you can see it on the website, if you go to the website, so you know what I'm talking about. The first presentation I gave was about embedded systems and an introduction to IoT. Some of the things, just like I mentioned in the first few slides. So first I sent them at home to go over some basic terminology, like what's the difference between microprocessors and microcontrollers, and what is GPIO or PWM, and what are sensors and actuators. And I actually gave them a few things to learn about MSB, LSB, little endian, big endian, and I sent them to do like a 5-10 minutes exercise. I also sent them a C++ guide for rust removal, because all of them are engineers, they know C and C++, but some of them may be coding for the past few years, I don't know, some high-level other language. So I wanted them to come when they already did some rust removal. We're not going to go over all of that, but I listed the main things that I went through on the first presentation. Some of them are just general embedded systems. I also noted and explained that embedded systems does not equal embedded programming. You can do an entire workshop about embedded programming, and it's not the same material. And also some things, there's a lot of things that are not here, like we didn't talk about memories or about a million other things that are related to embedded systems. But to talk about low-cost devices and power consumption optimizations is relevant for IoT. So when I needed to choose, I tried to make it more relevant. Aha. Back. Okay. So I want to share with you one of the slides that I particularly like. When we talk about smart devices, I think the question is just how smart can devices get? Okay, that's a bit of philosophy. And when I studied in the Hebrew University, I took a minor in cognitive science. In cognitive science that I needed to take cognitive psychology for. And we learned about different abilities and different, let's say, properties of us as human beings. We have perception, we have our sensors, our senses. We have memory, we are able to communicate very high level. We are able to demonstrate very complex behaviors, and we define ourselves as intelligent creatures. And that's some of the components that makes us human beings. And if we look at the devices I just showed you, we have sensors and they have sensors. They have memory, long-term and short and long-term. They have means of communications and the way to talk to the world about what they know. Some of them can demonstrate some kind of behaviors, and if they have enough memory, they can run algorithms that some of them could be very complicated. So I think that's really smart. Like, think about if you just want to measure something, and if a threshold is crossed, you want to ring a bell. Could you put a 3-year-old to do this task? No. 5 years old? I don't think so. 8 years old, maybe. 10 years old, probably. But you can take a low-cost chip and it will do that. So I think that's a nice way of thinking about the things we do. I don't think we should worry about machines taking over the world, but if we see how we define smart, we can look at these devices differently. Right. So now we're at our second part of the day. I had to teach Arduino. I didn't want to do that to begin with because I just didn't want to spend time. I wanted to talk just about IoT. But since I gave them some hardware and they had to use it, I had to teach that. So I wanted to teach Arduino, but I want to tell you how I did it. And it begins with a heartbreaking story. And that's when a few years back, after I had already maybe 5 or 6 years as experience as a software engineer, as an embedded software engineer, I said, oh, Arduino is cool. I'm going to go to a workshop. I found something around my house, and I went. And what happened is that I was sitting there with like an 8-year-old and his grandfather and a few more of this. And for 3 hours, we just blinked at it. And I was very disappointed. I thought Arduino is probably boring, and I didn't want to do the same for my participants. I wanted to teach Arduino for engineers. So what does it mean? Again, preparation assignment, I sent them home to read all the basics, so I wouldn't have to spend time on that. Like to explain what is the INO file, if you know Arduino, you know, that's just C++, all of that. What is the setup, what is the loop? And I actually sent them right away to read about libraries, because they know C and C++, it's basically things they can read and understand. I even sent them to read what the hex file format is. I didn't mean that they would read it and then they could, like the metrics, understand everything, but just to understand the process. So afterwards, when we're going to burn it to the system, they will know what they're doing. And also I sent them to do all the installation at home, so we won't spend any time on that. And this is already much more advanced than what people do with Arduino, because people can code to Arduino without even knowing what libraries are or to install a different board. And they did all of that before we even started. And then on the workshop itself, we just went through the terminology. When you say Arduino, people mean the community, and they mean the IDE, and they mean the actual company. All different stuff that if you don't know Arduino, it will take you time to understand. So we went through that, and through the board manager, compilation process, even talked about Arduino shields. So this is what we did, and then we went to the hands-on part. So I'll share, again, a few slides. I took that from the internet. We just went through that to see that it's not blue magic, it's hardware. We can go over it, we can understand what's on board, we can demystify Arduino. And also the same, to see what's behind the scenes, to check what's on your computer, to see that the libraries we use are there, we can change them, we can code them, to teach Arduino for engineers. The main part was the actual exercise that we will go over now. What I did in this part, the frontal lectures I gave them, and then I took a break, and they went and did the tutorials themselves. I invested a lot of time creating these tutorials, so in the workshop, they won't have to spend time, and they have all the materials. So basically, it's self-learning. It's a self-learning method, but they have mentors working around, seeing that no one is getting stuck even on the basic things. And the key thing to understand here, that coding C and C++ was not a learning goal for me. Because the engineer, they know that, and I don't care if, I don't need them to do more work writing the code if they can understand it. I just want to teach some other things. So now we'll just go over all the exercises and we'll see what I actually taught. There's the task goal, which is what they thought they were doing, and there was the actual learning goal, which was what I wanted them to learn. So the first thing we do, we just blink 3 LEDs. They got 2 LEDs already. They got the code blinking, and they just needed to adopt to light the 3rd one. But the actual learning goals was to look at the data sheet, to look at the board pinout, and to understand that, and for the first time, for some of them, to work with GPIOs. Now we added a buzzer to this setup, and the goal was to play a song with the buzzer, and every time a note is played, a different LED will blink. Again, they had 2 LEDs, they needed to add the 3rd one, but the actual learning goal was to start working with PWM that I sent them to read about in the preparation assignment. The 3rd task was to receive analog input from a photocell in order to detect the level of illumination in the room. And based on that illumination level, with different thresholds they had in code, 0 to 3 LEDs will be lit up. The actual learning goal was to read analog input and to react and do something according to a threshold. So you can see in the picture that if you take a flashlight and you put it on the photocell, all the LEDs are off because there's a lot of light outside. So until now, what we did, we didn't use the Bluetooth, we didn't use Bluetooth Low Energy at all. So after this part of the workshop, we gathered up again, and I gave them 40 minutes or 45 minutes of Bluetooth Low Energy, introduction to Bluetooth Low Energy. And I actually taught it pretty hardcore, just like I would teach someone who's joining our team and starting to code. Again, I gave them preparation assignments about general wireless communication. Like I sent them to read what is the electromagnetic spectrum and what is network topologies, what types do we have, and to get to know, just to hear the words master and slave architecture that are in a lot of other protocols as well. And the RSSI, received strength signal, and I sent them to see a quick 5 minutes Bluetooth Low Energy overview so they can hear about it before they come. And also I gave them a 7 minutes exercise with the NRF Connect app NRF Connect is a mobile application by Nordic Semiconductors that we use a lot while debugging Bluetooth Low Energy. You can basically just download the app, open it, and then you can scan and see what the devices that are around you. And for me, it's like magic. Like you just turn something on and you can see things that are in the air. And as I said before, the workshop itself was pretty hardcore. Most of them enjoyed it, generally. And what we did at the beginning, we looked over different types of wireless communications and the way we can compare them. Because there's a few different parameters that, if you look at the range and the data rate and the network topology or power consumption, that after a short talk, you can see the differences between the Wi-Fi I have at home and Bluetooth Low Energy. And even just for the participants to understand that maybe if they're listening to music, that's probably Bluetooth, but what we're going to code for is Bluetooth Low Energy. And it's not the same thing, especially Bluetooth Low Energy has lower power consumptions. So I thought that this is some good background, even if in the future they will work with some sort of wireless communication. But then I actually taught them the protocol, some of it. We talked about advertising and connection. We talked about the data modules. BLE eventually is a list of services, and each service has characteristics, and that's the way the device, the IoT unit that has information, can transfer that outside. We also talked a bit about the Bluetooth stack, and I talked just for a few minutes about development tools and specifically the sniffer and how do you debug to these kind of systems. So that's a slide that I really like that I wanted to share. That when I learned Bluetooth Low Energy, I didn't understand why this slide is important. It's from an introductory book. But then when you actually see that they can understand, we're going to work with this chip that I have up here. We're going to talk to him with our mobile phone, and I showed them before this tiny unit, so they can see in real life how these systems can interoperate. And I think it's pretty powerful to understand the design of protocols and how they're actually working in the real world. And another thing that I did that I kind of liked is that I showed them this. That's my sport watch that I have here. I showed it to them in the beginning of the lecture, and by the end of the lecture, we could look at it again and now understand how this band sends things and how it connects to the device and store all of it. And then this device connects with the mobile app and it uploads it to the server. So they could see the entire process and understand it after they went through the lecture. And even there's an additional thing here, because this thing has heart rate monitoring while you're wearing the band, but then it shows you your activity during the day, so it must have some other sensor here. You can now look at the graphs and understand that to do some sort of IoT reverse engineering. So now we went back. We did 2 warm-up exercises, and then the final exercise for the workshop. So this warm-up exercise was about transferring strings back and forth from the mobile phone to their Arduino serial port. And they do it over BLE, over Bluetooth Low Energy with this device. And the actual goal was to start working with Bluetooth Low Energy to see advertising, to have a connection with the mobile app. And also I sent them to read about the Nordic UART service, which is a logical UART. It's a service that has 2 characteristics. One is TX, transferring, and one is RX. And you can just like any other UART, but over BLE to transfer strings. And again, this simple drawing that I did in Paint, if you actually understand the entire process, you have a pretty good understanding of IoT and I think of embedded systems, if you can realize what is the process that's going on here. So that was an additional optional task. It was just to find the MAC address of the unit. I actually wrote it as a troubleshooting because I was afraid it will be too many people in the same room and they won't be able to recognize their devices. So not all of them did that, but whoever did the exercise got to work with Adafruit's IoT commands. And again, to work with BLE to see what the RSSI, you can see there in your drawing to understand what it is and to understand what the MAC address is. And the final exercise that for me was pure magic was to control the 3 LEDs they installed in the beginning of the workshop over BLE. So they can turn it on or off using a dedicated AT commands that I wrote over the Nordic UART service. So again, here they had to work with AT commands or to read about it. They could blink the LED without no strings attached. So if we'll see all the exercises and how they are built up, we can see that every exercise adds an additional component. So eventually they have a full setup. And within just a few hours, we were working for 5 hours in total, they knew basic electronics about GPIOs, PWM, analog input, RSSI, MAC address, AD commands, some familiarity with Bluetooth Low Energy, hands-on, a lot of familiarity with Bluetooth, but theoretical one, because they learned a lot, and something about services. So by the end of the workshop, they had communication both ways with their device. They had 2 different outputs and an analog input, and they now could connect the dots for themselves and to create something that is in its architecture is very similar to IoT devices. They could do additional things that I didn't even tell them to do, like to constantly read the photocell values and to stream it to the mobile phone. Or they can create their own AT command over the UART service, the BLE UART service, and to turn on the buzzer. They actually didn't have a lot of time to do it in the workshop, just one of them started to do that. But I think that after they did all the exercises, they could connect the dots themselves and do it. So some feedbacks. Engineers really like to write code, so they had to tell me that they wanted to write more code, but with the time limitation, I can understand why we couldn't do that. So they appreciated it, that coding in C and C++ wasn't a goal for me. And what I'm really proud of was that I didn't make them just blink a LED. What you can see here in blue is before the workshop, my background was, most of them said, I never worked with Arduino. And after the workshop, my ability to work with Arduino is, most of them said, good, I'm able to choose existing projects from the web and learn it on my own. And some of them, I was really proud, one of them said, great, I'm able to design a project on my own with the board and the parts and devices I'll choose, and even instruct others to do so. So I think that just to do the basic things, since I invested a lot of time in the tutorials so they could have the time, they can use the time well in the workshop itself. So yeah, for me it was I was really happy about it, especially due to the first experience that I had with Arduino that wasn't so good. So I just wrote down the questions that I asked during that process. I think it's relevant for any tech training and for any training test in general. So now when you know all that, thank you. Questions?
I have a question with respect to how you're trying to optimize the time that you have during the workshop by letting them study some documentation beforehand. As I imagine it, personally, I would be a bit frustrated having to read documentation about stuff that I cannot try out yet.
Frustrated about not being able to actually code?
To actually try it, because, well, people differ in how they accumulate new information.
Right.
Some people can actually read a document and just know what's inside. Other people work more visually. Other people work with their hands, etc. So I'm wondering, was that a feedback that you got as well? And on the other side, I was wondering, would it be a good idea to give them an Arduino even before the workshop starts, so everyone can program GPIOs, and then you can start from there?
So I gave them just theoretical things to do, mainly reading. It's all online. You can go and just see the emails that I actually sent them. It's true that about Arduino, they had to just do the installations and read about it, but I didn't have the devices beforehand, and I didn't want to. It's also a risk, because if you give it, maybe they won't show up, or maybe, I don't know. You should consider that. But you can see the emails. I tried a few things. First of all, I read the materials that I sent them to see that they're good enough and interesting enough. I try that it won't be too long because people will be impatient. And I try to send them to see a few videos or a short exercise and some articles. And I took into consideration that one of them actually wrote, I didn't do the homework. Or I asked them about feedbacks. A lot of them said that it was really good and it made them to be on the same page on the workshop itself. So there's a trade-off. But for me, it worked because I could do much more with the time I had.
Okay, thank you.
Anyone else?
Yeah, first, thanks for the presentation. My question goes in the same direction. That these preparation assignments seem to me pretty heavy. I mean, a lot of stuff. It seemed like it would take several days actually to go all of this.
Yeah, no, it was just about reading, a few readings, some Wikipedia entries.
Okay.
Some of them told me that if you have some experience, it could take just an hour. But I guess some of them, it took them some more time. But you can see them online. I think that, I don't know, when you have experience of a few years, it's sometimes hard to judge what someone who just graduated from school, how he will see it. So I tried that the links will be very informative, but not too long. And also I knew that if I'm sending them to read Wikipedia, they will probably just read the first paragraph. And if you want to do more, we had a few tracks, and actually some of the participants emailed us and told us, can you send me the other tracks, homework assignments, because I won't do them too. So it really depends. And you can see that you can come and do just the small exercises. They have all the codes and they have mentors. There's no way they could fail. There's only a way that they can learn more if they put the effort into it, and they can learn less and just have some fun with Arduino.
Okay.
It really depends on them.
In hindsight, after getting the feedback, would you change anything, or would you do the preparation assignments the same way?
I think that in the first part, I was lacking just going over some embedded systems, even just coffee machines or washing machines, and talk to them about them, or maybe ask them how they would design it. That's something that I would do that I don't have in the slides, in the first slide. I would definitely order the setup beforehand, because I had a few versions of it, and it took some time. I actually ordered the RGB LEDs, and I never ended up giving them exercise to do it because I just ran out of time. And specifically, just the tutorials took me so much time, I couldn't imagine how much work it would be. Because I think you take assumptions that I will find something online and I can just send it, and you need to wrap it up with a lot of explanations in order for it to be well understood.
Thank you.
Welcome.
Thanks for the presentation. What's the ratio of instructors to students? Because I've tried this in the past, and the level of frustration when something doesn't work and they need to debug both the software and the hardware can be high. So you need like a high number of instructors per student or something?
I'm not sure I understood. Can you repeat?
Yeah. What's the ratio between the number of instructors for the workshop and the students? Because it's easy to get stuck and frustrated because something doesn't work.
Okay. So I was there working around and helping if needed, and I had 2 more instructors, and I had a group of 30 engineers.
30?
Yeah. But again, they didn't need to code anything from scratch, so a lot of bugs were just prevented by that they got the code samples, and they literally needed to run it, to read it, to understand it, and tweak something. So if you let them do everything from scratch, I guess they will need more attention.
Okay, thanks.
More questions?
Thank you.
Thank you.